So this is the 2007B in the third section. And you see that they give you a graph and they tell you f of 1 equals 3. And it's two semicircles and two line segments. And part A says find all the values which f has a relative maximum, justify your answer. So remember, this is the first derivative graph, and you're going to have a max when f prime, or the derivative, changes from positive to negative. So it's going to be at x equal negative 3 and x equal 4. So part B says find all the values which the graph of f has a point of inflection, justify your answer. Now remember, we're looking at the first derivative graph. So what's the correlation in point of inflections? That's your second derivative when it changes from positive to negative. Well, the correlation with the first derivative is where it changes from increasing to decreasing. So x equal negative 4 will be a point of inflection because it changes from positive to negative, from increasing to decreasing. X equal negative 1 is a point of inflection because the derivative changes from decreasing to increasing. And x equal 2 because the first derivative changes from increasing to decreasing. Now part C says find all the intervals which f is concave up and has a positive slope. Explain your reasoning. So remember, it's going to be concave up where the first derivative is increasing, and it's going to have a positive slope, obviously, where it's positive. So if you look at the graph, it's going to be from negative 5 to 4 and from 1 to 2, because that's where it's increasing and a positive. Part D, find the absolute minimum value over the closed interval. Explain your reasoning. Now, remember, absolute minimum, you need your endpoints and where it would be a minimum. Now, it's going to be a minimum where it changes from negative to positive, because that would be decreasing to increasing. So that happens at x equal 1, and your endpoints are negative 5 and 5. So remember, on all of these sections, we start with our starting point, and we go from 1 to negative 5 of f of t. And we got f of 1 we know is 3, and f of 5 we go from f of 1 from 1 to 5 f of t. Now I've done the actual work down here. So at f of negative 5, you have to change the integral to subtraction because these were out of order. So you're going to get 3, and then you're going to use your geometric shapes. So from negative 5 to negative 3, we have a semicircle. And then from negative 3 to 1, we have another semicircle, but it's going to be negative because it's under the x-axis. So if you put all that together, you get 3 plus 3 pi over 2. Now again, f of 1 we know because it was given to us, and f of 5 equal 1 plus, if you go back and look at the graph, you're going from 1 to 5, so you're using the big triangle and the little triangle. So that's the big triangle, and then we're going to do minus for the little triangle because it's below the x-axis, and you get 3.5. So the absolute minimum is going to be at f of 1 equal 3. So now we're going to look at the 2006. You see you have graph of f, the original function, and it says the graph of f consists of 6 line segments, and then g of x is equal to 0 to x of ft dt. So it says find g of 4, g prime of 4, and g double prime of 4. So g of 4 would be the integral of 0 to 4 f of t. So we're going to come up here and go from 0 to 4. And so we have a triangle that's underneath the x-axis, and then we have the trapezoid here. So if you add all that together, negative 1 plus 4, you get 3. Now g prime of 4, remember, second fundamental theorem of calculus, if I take the derivative of this integral, it's just going to be f of x. So that's going to be g prime of 4 is f of 4. So I go here, and that's equal to 0. Now g double prime of 4, I'm going to use my slope formula here. So I'm going to do 2 minus negative 2, 3 minus 5, and I'm going to get negative 2. Part B says, does G have a relative minimum, a relative max, or neither at x equal 1? Justify your answer. And it's a relative min because remember G prime of x is equal to f of x, and if you go to 1 it changes from negative to positive, and so that's going to be a relative min. So part C, suppose f is defined for all real numbers and periodic with a period of length 5. The graph above shows 2 periods of f. Given that g of 5 equal 2, find g of 10 and write an equation for the line tangent to the graph of g at x equal 108. So you know g of 5 equal 2, so that would be 2 intervals to get g of 10. So basically it's 2 times g of 5. I wrote g of 10, but g of 10 would be equal to 2 of g of 5. So that would be 2 times 2 would equal 4. So that's what that is for g of 10. Now it says write an equation for the tangent line at x equal 108. So g of 108, if you divide that by 5, you're going to have 21 and 3 left over. So we're going to do 21 times g of 5, which will be 42, plus 0 to 3 of f of t. So f of 3. So we would do 42, and then we would go up. We're at 3. So we're doing 0 to 3. So we're doing this little triangle and this small part of the trapezoid. So if you do the little triangle below the x-axis and the trapezoid, you get 44. So that's your ordered pair, because remember you're writing a tangent line. So then the derivative of 108 will be f of 108, which remember it cycles. So basically you had 21, that would be g of 5, and then you'd have 3 left over. So f of 3 equal 2. And so you're going to come up here, because remember the derivative of g is equal to f. So you just get that from your graph. And so then you just plug in y equal mx plus b, and you work it out, and you get 2x minus 172. So let's look at the 2006 Form B. They give you the graph of the first derivative. They tell you f of 0 equal 5. They even give you the function rule of the first derivative. And part A says use the graph of the derivative to determine if f is concave up, concave down between 1.7 and 1.9. So if you put this in your calculator, you'll see 1.7, 1.9 falls in here. What is the first derivative doing? It's decreasing. So if it's decreasing on this interval, it'll be concave down, because that's the relationship. Now part B says on the interval from 0 to 3, find the value of x, which f has an absolute maximum. Justify your answer. So we're going from 1 to 3. Now remember, maximum, if you're doing absolute, you're going to check endpoints and also for where it's changing from positive to negative. So the endpoints are f of 0 and f of 3, and f of 1.7 is where it changes from positive to negative. Well, we know f of 0 is 5 because they gave it to us. F of 3 will be f of 0 from 0 to 3 of your derivative. Well, this is a calculator active, so you can use Math 9 because they gave you the function rule. And the same thing on f of 1.7, f of 0 from 0 to 3, use Math 9. And so of the 3 figures, the absolute max is going to fall at f of 1.7. So part C says write an equation for a line tangent to the graph at f of x equal 2. So if we're writing a tangent line, we need an ordered pair and we need a slope. So f of 2 would be f of 0 from 0 to 2 of the derivative. Again, we can use our starting point and Math 9. And we get that as our ordered pair. and f prime of 2 is negative 0.459. You would do math 8 on that because you've got the function rule to figure out what that is. So I'll write that down if you're looking back at it. That would be math 8. And then I'm just going to plug it in and write my tangent line. So let's look at the 2005 one. They give you a graph. It tells you the car's traveling from 0 to 24. This is the velocity graph. So A says find 0 to 24 velocity. Use correct units. This is a non-calculator one also. So you're going to do 0 to 24, V of 2, and you're just going to use your shape as a trapezoid. So you're going to do 1/2, 20, 24 plus 12, and you're going to get 360 meters. And this is the amount the car travels, 360 meters in 24 seconds. Now part B says for V prime 4 and V prime 20, find the value or explain why it doesn't exist, indicate units of measure. So V prime 4 does not exist because if you look at 4, look how the slopes are different. You've got positive slope and then you've got 0 slope. So since they're not the same, that doesn't exist. V prime of 20, I can come here. 20 is this point right here. And I'm going to use the slope formula. So it falls on this line, so I can use these two order pairs to get my slope of that line. And you get negative 5/2 meters per second squared. So C says let A of t be the car's acceleration in meters per second. For 0 to 24, write a piecewise defined function. So remember, acceleration is the slope of velocity. So from 0 to 4, I'm going to do my slope formula, and I'm going to get my slope to be 5. So I'm going to write a piecewise 5 from 0 to 4. Well, you can look at the picture and see what the slope of this is. So from 4 to 16, it's 0. And then we just did the slope of this line in part B. It's negative 5/2. So that's how I'd write my piecewise function. And D says find the average rate of change over 8 and 20. Does the mean value theorem guarantee a value C that is equal to this average rate of change? Well, remember, average rate of change is just V of 20 minus V of 8, 20 minus 8. You're going to get 5, 6. And mean value theorem does not guarantee this because on the mean value theorem it has to be differentiable on the entire interval. And we know that it is not differentiable at t equals 16. It's not differentiable at 4 either, but this was between 8 and 20.